There are multiple steps involved in a linear regression analysis. I've typed for you here some basic steps that I'll expect you to be able to perform. And this picks up after you've already done some preliminary steps, including exploring your variables, making sure you understand what they are, seeing if any cleaning needs to take place, looking for outliers, that kind of thing. Once all of your preliminary steps are done, then it's time to look at your scatter plots. Your scatter plots will reveal to you whether or not a linear relationship could exist between two of your variables. And if you see that perhaps some are linearly related, look at your strength of correlation, your correlation coefficients. Then run procreg and look at your output. And for our purposes, we're interested in particular with R-squared, significance, and the residual plots. If we're happy with everything, we'll go ahead and write our equation and use it to make a prediction. So let's go ahead and run through an example. The data set I'm using in this example is in your SAS help library, and it's called CARS, and it's similar to the vehicles data set that you're using for the first few weeks of the course. It's not the same, but it's similar to. And there are multiple variables in this list. I'm choosing to look at these four in particular in a scatter plot matrix. Let's run this and see if any could be linearly related. All right, we have some discrete variables here, which is why some of these graphs are looking a little bit like staircases. When we have continuous variables, we'll have something that looks more like this graph here, which compares engine size to horsepower. And that pair looks like it could possibly be linearly related. We'll take a look at each pair, and we read this by looking at across with this variable and down to see which one's written. So this particular graph is engine size on the X and cylinders on the Y. And this particular graph is horsepower on the X and engine size on the Y. So that's how you read those results. Now let's go back to our code. Engine size and horsepower looked like they could have exhibited a linear relationship, and I want to know how strong that relationship is. So I will include those variables in a proc core step. And let's take a look at those results. And we see in, let me make sure that this is not obscured. Here we go. That our coefficient is 0.787. Now, the ones that you see here are just comparing a variable to itself. You can ignore those. The horsepower to engine size is what we're interested in. And you'll need to refer to the information provided in the PowerPoint to know how strong this is. And this is actually a strong positive relationship. All right, so now let's go back and go with our next step. And that is to run our regression analysis. And we'll need a model statement here. And it's very important that you understand how to write it in terms of which variable is to the left of the equal sign. And that's the one you're trying to predict, or the response variable. How does horsepower respond to engine size? All right, so I'll put horsepower on the left and engine size on the right of my equal sign in a model statement. And we will run this. And now we'll take a look at our results. Pay attention to R squared, and you need to be able to interpret that. And what this is telling us is 62% of the variation in horsepower is explained by engine size. And we'll look at the significance of the variables we have here. Don't worry too much about the significance of the intercept. Look at significance of the engine size. So this p-value here should be less than 0.05, which it is. And then take a look at your plots down below, particularly the residual plot versus predicted value. There shouldn't be any pattern there, and I don't see any pattern. And then below, the quantile plot, and those values should hug pretty closely to this diagonal line. And most of the values do, although I can see that at the upper end, they're starting to veer away from that line. So at this point, it's a judgment call whether you're going to proceed or not. And just to continue with the example and show you the remaining steps, I am going to proceed. And here are some more plots that we can examine. Now let's go back up to the parameter estimates table. These two values are going to go in our equation. I'm now going to show you how to write the equation by hand and how to calculate a prediction. And I'm also going to show you how to do it programmatically in SAS. All right, so by hand, let me bring up this. We're going to write an equation of the form y equals mx plus b. This is probably what you remember from high school. But I'm going to rearrange it a little bit. I'm going to first say, since this is a model and not exact, I'm going to use y hat. That tells people this is an estimate. And I'm going to switch the order of my terms. So my beta is going to come first, my intercept, and I'm going to write it as beta 0. And then I'm going to write the slope as beta 1. And that goes with my first variable. And I'm writing it this way because as we advance to multiple linear regression, I could add additional terms here if I wanted to, but we're not going to do that today. All right, so now I'm going to put our numbers in. Let me see what those were. The intercept is 52.77, approximately. And my coefficient for engine size is 51.03, approximately. And let me expand this and write in the variables just so this has a little bit more meaning. Remember that we are modeling horsepower using engine size. So horsepower is my Y, and engine size is my X. All right, this will help when we're trying to plug in. All right, now engine size is the same thing as engine displacement. So in your vehicles data set that you're using, that's the dispol variable, and it's in terms of liters. And what I'm going to do now is the last step of the process. It's going to use this equation to make a prediction. I'm going to predict the horsepower for a 2-liter engine size. So I'm going to plug in 2 right here. And I'm going to bring up my calculator and figure out what this will be. So I've got 51.03 times 2. And then I'm going to add to that 52.77. And my prediction is 154.83. And they'll have to know what my units are for horsepower. I don't know if it's horses or watts or some other unit. I'd have to know that to be able to say something meaningful with this prediction. All right, so that's how we do it by hand. And when I did it by hand, I approximated these numbers just to make it easier. What we're going to do now is preserve all of the digits and do this programmatically so that there's no room for error. So let's go back to SAS. We will minimize our calculator here and compare what we get programmatically with what we approximated. All right, so programmatically, we would run the same procreg step that we just did, but include the following option. Outest equals something, and I'm just going to call it estimates. What this is going to do is take the values that were in my parameter estimates table and send them to a data set in the work library. So let's take a look here after we run this step. I've got this estimates table here. Now see these values down here, 52.77, 51.02. Let's open up this estimates table and let's see what we've got here. Intercept, 52.77, engine size, 51.025. So those are the values that were spit out to us in a results table. They're now in a data set so we can use them. And then I'll continue. Because those values are in one data set and my other values are in that SAS help.cars data set, I'm going to create some macro variables for my intercept and my slope. And oops, I don't want this to be height. I want this to be engine size. Let me make sure that that was how it was named. Yes. All right, so I'm going to run this piece of code, which creates my macro variables. We're not really going to see anything taking place except some notes in the log. And then what I'm going to do is make a third macro variable for the X value that I'll be plugging in. And we want it to be 2. That's the prediction I want to make. What will the horsepower be for an engine size of 2 liters? So I'm going to run these next 2 steps and a data step that calculates what I did by hand. It'll take those macro variables and do what I did in the calculator, and it will output it to a new data set, and there'll just be one single value in that data set, and that's going to be our prediction. 154.822. Let's bring out the calculator. We did this by hand and got 154.83, so very close to what we get programmatically. And that concludes this video on the steps involved with linear regression.